are going to learn how to derive using the power rule. That's the first thing we're going to learn, and the next thing that we're going to learn in this video is how to integrate. Now starting off with the power rule, say I'm going to make an example of a function. I'm going to use the function of x is equals to f at x is equals to 3x squared plus 2x plus maybe 4 here. So to find the first derivative of this function using the power rule, we are going to say, first, before I do anything, let me just rewrite this. It's going to be f of x 3x squared plus 2x plus 4. So to find the first derivative here of x, we are going to take this exponent, the power rule. With the first rule of the power rule we're going to follow, or the first principle that we're going to apply using the power rule, we're simply going to take our exponent of the variable and multiply it by the coefficient of the variable. So here the exponent of this variable is 2. The exponent of this variable is 2, then multiplying with its coefficient, which is 3, the coefficient of the variable, that is. So 2 multiplied by 3 is going to give us how much? It's going to give us 6x. Now to the exponent, what we're going to do to the exponent now, the power rule tells us that to the exponent we have to subtract 1 to the exponent of the variable. So if we had the exponent of 2, then we're subtracting 1, then we're going to get how much? We're going to get 1, because 2 minus 1 is 1. Now for this side, we're going to do the same things that we did this side. So this side we are going to have your exponent being 1, because any variable, any number, any constant is to the exponent 1, because any number to the exponent 1 gives you that particular number, so it makes no difference to add the exponent of 1. Now we're going to take this exponent of 1 multiplied by the coefficient. The exponent of 1 multiplied by the coefficient, 1 plus 2 minus 1 multiplied by 2 is going to give us 2. 1 multiplied by 2 is going to give us 2. X to the exponent, what did we do here? We subtracted 1 from our original exponent, which was 2. So now our original exponent is 1. We are going to subtract 1 again. We do the same. Here is 2x to the exponent. 1 minus 1 is going to give us 0. And then the derivative of any constant. A constant is the number that doesn't have a variable next to it, a number that doesn't have an alphabet next to it. That is a constant. So a derivative of the constant is 0. So here we're going to write 0. Now moving forth, we are going to rewrite this. We are going to have we're going to further our simplification for this derivative. We're going to have 6x. We're going to have 6x, because 6x to the exponent 1 is actually 6x, and then we are going to add it with what? With 2. And then what happens here now? X to the exponent 0, that is going to give us 1. So it's 2 multiplied by 1. So any number to the exponent 0 is 1. You can leave maybe a question in the comment section regarding why that is, and I'll make it a goal to explain thoroughly in details or in depth why any number to the exponent 0 is 1. But for now, you are going to take that as is. X to the exponent 0 is 1, and then the constant, we reduced it to 0 through deriving. Now we are going to have our first derivative of the function of x being 6x plus 2. That is how we apply our power rule to. That is how we apply our power rule to derive or find the first derivative of the function. So now how do we integrate? Now say we have let me just clear this thing, and integration. Now I'm gonna explain integration in a way that you are going to remember it. Integration is simply the reverse of the the derivative. So it's anti-derivative, some people call it that. it's actually reversing the derivation using the power rule. Mostly we use the reverse of the power rule to integrate. You'll understand that when I explain, after I explain. So now there, let's say you have the derivative of a function being here we have 6x plus 2. Say we have 6x plus 2, and we don't know what our original function is, suppose. And then in order for us to find the function, or to have the idea of what the original function of this function of this derivative looks like, we have to find an integration. How do we do that? First of all, we are simply going to say the function of x is going to be what? The integration. So this is the integration bracket that we're going to use, and then the integral of 6x plus 2 dx. So this dx tells us that this here is the derivative of a certain function. So that's what this dx tells us. And then continuing finding the derivative now. Finding the integration. Finding the integration, we are going to do the reverse of the power rule. So the power rule told us that we need to subtract 1 to the exponent. It told us first to do that, to take the exponent and multiply it by the coefficient. Then we subtract 1 to the exponent. So we're going to work backward. We are going to add 1 to the exponent and then divide the whole thing by the product, by the sum that we're going to get after adding 1 to an exponent. And then that number dividing the coefficient, we are going to find what we had in our original term. Let us apply that. Let us do that practically. Then here we are going to have f at x being equals to the derivative, or the integration of the first term, which is 6x. We have the exponent of 1 here, and I explained why we have an exponent of 1 if the variable appears to have an invincible or doesn't appear to have any exponent. It has an exponent of 1, and then we are going to add 1 here. When we add 1 to this exponent, we are going to get 2. So adding 1, we are going to get 6x to the exponent 2, because 1 plus 1 is 2. Now after that, we take this sum, which is 2, 1 plus 1 is 2, divide the whole thing by that sum. So we're going to divide both 6x with 2. Let me write this clearly here and remove this bracket. Here we divide it by 2, and then plus. We're going to do the same with the next term. So here we have 2, we have the just 2, né? And this dx, remember I told us that this is what? This is actually the derivative of a certain function. So we are going to plug in x right next to 2. We are going to say 2x, because when you have a constant in your derivative, that will simply mean you had previously the variable that you reduced its exponent to 0, and that exponent 0 changed it to 1. Remember what I said here. This 1 minus 1 changed to 0, and that 0 changed this x to be 1. And then multiplying 1 by that gave us this constant in our derivative, in our first derivative. And then here, this side, this will simply mean now we have to plug x here, and then plus the constant. Now I told you here, or I explained that the derivative of any constant is 0. So if the derivative of any constant is 0, this will make it difficult for us to move from 0 to a specific constant, because all the constants, they tend to 0 when you derive them. So we are simply going to add here, this side we're going to add constant c, because we cannot find the integration of a specific constant, if that makes sense. not sure, but if it doesn't, I'll hear that, or I'll see that in I assume I'm gonna see that in the comment section, so that I make it a goal that I explain in a way that you understand. So 6 divided by 2 is going to give us how much? It's going to give us 3. Then we're going to have x squared plus 2x plus c. That's going to be our original function. This is how you find out the idea of the original function using integration. Thank you for tuning in. Thank you for listening, paying attention. And if you have any question, if you have any concept that you would like me to explain or break down, please leave that in the comment section, and I am going to make it a goal to explain it. For now, you can subscribe, like the video, and thanks for the support.